All right, I want to welcome back Hononegah, Algebra 2, Section 4-5, Day 2. We're going to talk about what's known as the possibles. And this is kind of a situation that what would happen if I didn't have a graphing calculator and I needed to know what the possible solutions are. So it's kind of like getting a word bank or kind of like getting a number bank. This would give you the numbers that you could actually use that could be a solution. Again, the word possible solutions. So what we're going to do is always take the p-value and the q value. So the a sub 1, the last number in any particular situation is the p-value, and the lead coefficient is the q value. So again, and it's all the factors of those. So again, this is going to get a little bit confusing here, but here we go. So I want to know what the possible, and this is going to be on your test. I don't want to actually solve this. Okay, I just want to know the possible solution. So I'm going to take the ending value, the 8, and come up with all the different ways to actually multiply to be 8. And then I want to come up with the lead number, which is 5, and all the different ways that you could possibly get 5. So 1 times 5 is the only way you can get 5, and then 8 is 1 times 8 and 2 times 4. Now, all the possibles is plus and minus all the p-values over all the q-values. So every p-value goes on top and every q-value goes on the bottom, and it's every possibility of that. Meaning, I'm going to take 1 over 1, and then I'm going to take 1 over 5. So that is the 1 over each of the q values. Then I'm going to do the same thing for the next one. So 2 over 1 and 2 over 5. And the next one is 4 over 1 and 4 over 5. And the last one is 8 over 1 and 8 over 5. So notice that I took all of the p-values, each one of these, and divided it by each one of these. That is the possible list. Now, it's not the actual list. It's not the ones that really work. These are the only ones that could work. So I want to make sure that I am highlighting that this is the situation that you're talking about the numbers that could work, not the numbers that actually work. So this is called the rational root theorem. Now, the next question, they want to find the ones that actually do work. I could go through and find the possibles. I'm not going to, nor will I ask you to, but you could, okay? I'm going to actually do it in this section, but this is not something that's required. So I just want to make sure you understand how to do this. So 3 and all the ways to get 3, and then 48. And what makes this question nasty is the fact that there are a lot of different ways to get 48. So the possibles list, and again, I'm going to put this kind of off to the side here, and this is not something you need to do, but here's the p-values, here's the q-values. So I'd have 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, 1 over 8, 1 over 12, 1 over 16, 1 over 24, and 1 over 48. So those are all the ones for the 1 over the q. Now I'm going to do the same thing with the 3. 3 over 1, 3 over 2. 3 over 3 is a repeat. It's back to 1. 3 over 4. 3 over 6 is back to a half. 3 over 8. 3 over 12 is back to a fourth. 3 over 16. 3 over 24 is back to an eighth. And then 3 over 48 is back to a 16th. So there it is. That is the possibles list. So I'm going to actually show this, and I'm going to go get my graphing calculator out, and that's what makes this possibles list a little bit outdated. But ultimately, this is how I would have to do it if ultimately I did not have a calculator. So I'm going to guarantee when we solve this, the only zeros that we're going to get are going to be the zeros that come out, or the rational zeros that we get are going to be off of this list. So let's go to a graphing calculator. I went ahead and typed it in for us. So all of you that are at home or watching this video, hit pause and type this in. All right, so I typed it in. I'm going to hit graph, and you're going to notice that it's all over the place. Like there's where it's crossing the x-axis, I can't really tell what's going on. And so I want to know, if I go to the table right now, I'm not going to see any zeros. So I'm going to teach you something today. I want to get, instead of going by ones on the table, I want to go by smaller increments. So I'm going to go by increments that ultimately I can see some fractions. So I'm going to go to table set, second window, and see where it says change in table by 1 or table equal 1. I want this to now go by a decimal. I want to go by 0.25. And that's my recommendation. Anytime you're going to change and look for fractions, let's start with 0.25. So let's now go to table. And all of a sudden down here, I finally see a 0. Look, negative 0.5 is a 0. So let's go verify that. Let's go actually see if that works. So I want negative a half. 48, negative 52, 0, 13, and negative 3. Notice that I put a 0 in for the x squared that wasn't there. So the first one gets pulled down, multiply, add, multiply, add, multiply, add, and then multiply again. And add. Notice it ended up being a 0. So that one works. Okay, and notice it's over here on the list. It's right over here, positive a half or negative a half. Now, I need another one. So I'm going to go back to my graphing calculator and I'm going to look for another 0, and I see a half. Positive a half also works. So from this answer, I am now going to also do the next one. So 48, multiply and add, multiply and add, and then multiply and add. And now I am down to a quadratic. So I don't need my calculator anymore. I can now solve quadratics without the use of a calculator. I could use a variety of methods, quadratic formula, factoring. Those are probably the two methods I'm going to use the most. So I'm going to solve this by factoring. They're all divisible by 4. So I'm going to make this a little bit smaller and multiply it by 4. And then I'm going to try to factor this. So 3x and 4x, a minus 3 and a minus 1. So x is equal to 1/3 and x is equal to 3/4. So notice all of those are options here. Positive 1/3 is right there. Negative 3/4 is down here. Okay, and if I went over to the graphing calculator, remember you went by 0.25, so you're not going to see the third, but I am going to see the 0.75 or the 3/4. So now, I have to verify this algebraically. You cannot just use the graphing calculator. You must actually show that you get remainder of 0 and your 4 solutions to the question. Next one. This is called the irrational conjugate theorem. Here's what it basically states. If any time you have an irrational answer, x squared equals 17. Notice, anytime you have an irrational answer, you will always get a positive and a negative. So if I have an answer of 3 plus the square root of 2, then 3 minus the square root of 2 must also be an answer. This is called the conjugate. Okay, you're going to need to know conjugates later when we start rationalizing denominators. But conjugate, 3 plus the square root of 2 and 3 minus the square root of 2. If one is an answer, the other one is an answer. Well, that's going to lead us into this. I'm going to give you the answers, and I'm going to ask for the question. We did this earlier. So x is equal to 2, and x is equal to 3 plus the square root of 7. What they're not telling you is that x must also equal 3 minus the square root of 7 because of the irrational conjugate. Here's the answer. Make them all equal 0. These are the factors. I take the factors and FOIL them. Now, always do the irrational ones first. I'm going to give you a helpful hint here. X times x is x squared. X times negative 3. And then x times the square root is 7. Next one, negative 3 times x. Negative 3 times 3. And negative 3 times the square root is 7. And then the last one, negative x squared is 7. Positive 3 square root is 7. And negative square root of 49. Here's what you're going to notice. Anytime there's an irrational one, it cancels. So when you multiply by the conjugate, and by the way, this is 7, you will always get rid of the radical. Now I'm down to a situation that I only need to FOIL one more time, but I no longer have any radicals involved. So here we go, x cubed, and I'm running out of space. Negative 6x and negative 2x make negative 8. X squared. And we have a positive 12 and a positive 2, which makes a positive 14x, and then a negative 2 times a positive 2. So this would be the question if these were the answers. So everything is being done backwards. Questions on that? Well, if you do have any questions, make sure you talk to your teacher. Your homework assignment tonight is a worksheet, fairly short video here. If you, again, have any questions, make sure you talk to your teacher, and good luck.